Hey everybody, let's spend a little bit of time talking about acid-base theories, and there are three big ones that we tackle in this class. There's going to be Arrhenius theory, which is kind of the most simplistic. There's Bronsted-Lowry theory, which is maybe the most useful, and then there's Lewis theory, which I would say is maybe when like the theory of last resort. If you know something is an acid or a base, but you don't know why it's an acid or a base, it's probably because it's a Lewis acid or base. Okay, so let's talk about Lewis theory. Okay, let me get rid of my mug here, and then let's say that Lewis, yeah, the same Lewis that did Lewis dot structures also did Lewis theory. Actually, I think that the Lewis theory of acids and bases came from Lewis dot structure, was first, and then the Lewis dot structures were used to describe what the theory, and then so if we remember kind of Arrhenius and Bronsted-Lowry, we're really looking at protons. Okay, but in this compound, when we're dealing with Lewis, we're really looking at electron pairs. Okay, and with electron pairs, we kind of switch it up from Bronsted-Lowry, and we say that in Lewis acids accept. So for Lewis acids, I don't know why that keeps showing up, but for Lewis acids, we accept electron pairs. So we're really looking at the electrons, and then the opposite is obviously true for the bases. So let's move along. So, and this is what I was saying in the intro. It was if kind of the method of last resort to determine whether you're dealing. If you can't tell that it's Bronsted-Lowry or Arrhenius, then it's probably going to be a Lewis acid or base. I will say that there are other theories of acids and bases, like hard-soft acid-base theory, that go into some really crazy, like some pretty deep chemistry. So there's a ton of acid-base definitions, but these three are kind of the most important. So let's do an example here of ammonia reacting with boron trifluoride. Okay, and so let's look at this reaction and see which one's going to be the acid and the base, because this is, believe it or not, an acid-base reaction. And so we go here and let's draw the Lewis structure. Now I kind of know what this is going to look like, so I'm going to do this to kind of help with the understanding. I'm going to draw this so that it helps with the understanding of the. And so there's all sorts of electrons around here. Okay, and so this forms a coordinate covalent bond, an unequal sharing of bonds. But in red, here's what's happening. These two electrons are going to react here with boron, and it's going to form a bond. So there's going to end up being a bond, a coordinate covalent bond there, but nonetheless a bond. So what has happened? The nitrogen has extra electrons, so it has donated electrons, and boron has space for the electrons, so this has accepted the electron pair. Okay, so that means that nitrogen is the base and BF3 is the acid. Now, one of the things that I do want to point out is that if you have defined something as an acid in one system, like if we know that this is a Bronsted-Lowry acid or Bronsted-Lowry base, okay, that is probably going to be a base in most of the other systems that we've dealt with. Okay, there's some examples of conflicts, but I think that in general, especially in these introductory chemistry classes, once we've defined something as being an acid or a base, it kind of stays an acid or a base. And so you may recognize this as being a Bronsted-Lowry base, and it is. But BF3 isn't readily available. There's no hydrogens to donate, and there's no H's or OH's out front, so we don't really know what's going on here. And so the only way that this can describe anything is when this is is just by Lewis theory. Okay, so that explains Lewis theory, and have a great day.